Welcome to Domain and Range Part 3. In this we're going to look at a couple of examples where we combine both radicals and denominators together so that you can see what to do in these situations while finding the domain. Alright, now remember from our previous work that restrictions on the domain can occur from radicals or from denominators, and in this case you have both in this situation. So what I want to do is I want to look at the numerator first. And we know in this particular case that x minus 3 has to be greater than or equal to 0, or x has to be greater than 3. Okay, that's for the numerator. And in the denominator, we say x plus 2 cannot equal 0. So we say x cannot equal negative 2. Now you have to make a decision here. One of these, it's either a combination of both or just one part of the domain. Now I want you to look at this. This tells me that x has to be greater than negative 3. So would we even take this into consideration at all? No, we do not. Okay, so the domain, the overall overriding domain, is the more restrictive of the two domains. So we look at this guy as our answer. Okay, well it doesn't seem that bad, does it? Well, let's then look at another example. Let's say we have this. Here we have this case. Very similar question, except for this time the radical is on the bottom. Now this combines the radical and the fraction into the same denominator, into the same concept. And then actually we don't even have to worry about the numerator because really it's not restricted, because it's not in the bottom and it's not covered by a radical. So now all we have to do is worry about this. Now in this circumstance, because the radical's on the bottom, instead of saying greater than or equal to 0, we say it has to be greater than 0 because we can't include the 0 in the problem. So then we just get this is our domain. X has to be greater than negative 3. All right? Well, let's do one more and you'll get the general idea here. We'll do this, and we'll do this. Okay, so once again, we have the dual domain issues here. We have this, okay, the numerator, which has a radical in it. We have to compensate for that. So we say x plus 8 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to negative 8. That's all well and good. We like that. But then we have this to deal with. X squared minus 16 has to not equal 0. So in other words, x cannot equal plus or minus 4. Now remember before I said you have, in this circumstance, you have to choose the more restricted domain. Okay, and this is pretty restricted. However, notice if you actually look at all this on a number line, say if I draw a number line here, here's my number line, all right, here is negative 8, here is negative 4, and here is 4 on the number line. Okay, now what this is telling me is, what this guy tells me, I'm taking this number and everything above it. But wait a minute, everything above it includes these two guys. So what we really have going on here are these two are being eliminated from the picture. So when we write our domain, we have to compensate for that because they're within the zone. So you say, one way to say it is like this. You just write both parts of the domain we found before. Okay, now if you're writing this with interval notation, you say negative 8, comma 4, or negative 4, or negative 4, comma 4, or 4, comma infinity. You have to be very careful as you're writing that. All right, that's the end. Thank you very much.